Color Bank here to show you a little bit about what's going on with 1 divided by 0 and how it relates to calculus. Okay, 1 divided by 0. What a interesting thing to look at. Because if we just put this into a calculator, as so, we get that it is undefined. Which is weird, although it should make sense, because we can't really divide by 0 things, but it's still weird that all of a sudden this basic operation would be undefined. So why is it undefined? Well, let's look at stuff that's like really close to that somehow. So first we'll look at something like just this, very intuitive series, 1/2, 1/3, 1/4, and so on. Technically known as the harmonic series, but more on that later. And it's really, as the denominator gets larger, the fraction gets smaller, right? This is something very intuitive that you have seen very early on in your math classes, right? Smaller fraction, larger denominator. There it is, right? Very technical math notation here. Not really. But we have, really big number in the denominator, really small number then for the fraction. In limit forms, this is interesting, this limit as x goes to infinity. So as the x, which in this case with the 1 over x means x in the denominator, as the x gets larger, that means that the limit is 0. Because what happens with really small numbers as they get smaller and smaller and smaller, they approach 0. So think of this limit as like approach. Okay, let's scroll down a little bit and see what happens if we look at negative numbers. It's pretty similar, right? So the idea is do all the same stuff we had, but instead of like, a really big number, it's negative a really big number, which means we have a negative really small number. And if we put that in limit form, again, what happens to a negative really small number? Well, as it gets smaller and smaller and smaller, again, this would be like negative like 0.0000 whatever, that eventually approaches 0 as well. All right? The only difference here is that x is going to now negative infinity. So it's just getting like really big, but negative. Okay, that's all nice and good. So what happens if we sort of invert that a little bit? Right? Like look at these numbers here. Think about it for a moment. Now our denominator is getting smaller, right? From 0.5 to 0.25 to 0.125. Interesting, cool. And what are these numbers? Well, 1 divided by 0.5, that's 2. 1 divided by 0.25, that's 4. And 1 divided by 0.125, that is 8. So these numbers are actually getting larger. So you'll see that's kind of like the inverse of what we had. In limit form, this is now, and again, these are all positive. So we say the limit as x goes to 0. Notice this plus here, okay? That is like positive numbers, and it really is numbers that are to the right of 0. So this is what we actually call a right-handed limit, since we approach the limit from the right. Although it's like we are moving left. So let me just go to the number line for that real quick. Come back to this, but it's like, okay, we're over here, and if we're approaching 0, we're technically going left, but we're on the right-hand side. So that's why we call it a right-hand limit. Okay, and so you'll notice in this case, we put a infinity factor. It's like it's getting larger and larger and larger. As this gets closer to 0, this gets larger and larger, so that we say the limit is going to equal infinity. Not that infinity is a number, but again, it's a limit. It approaches infinity. Negative numbers have a similar initial setup, although you'll see the conclusion will be different. Here's what I mean. Similar setup to before, right? Negative really small number, negative really big number, cool, awesome. But notice what's going on with the limits. We're now approaching 0 from the left, okay? So negative numbers approaching it from the left, and that means our limit is going to be negative infinity. So wait a second. To summarize this, well, first, actually, let me say that we call that a left-handed limit, whereas the other one is a right-handed limit. This is a left-handed limit because we're approaching it from the left. So on the one side, we can approach 1 divided by 0, because this is actually getting at the question asked before, right? What happens as x gets closer to 0? Well, if we approach it from the positive side, we get positive infinity. But if we approach it from the negative side, it becomes negative infinity. Okay? Just put both of these back together here. How can something from one side go to positive infinity and then from the other side go to negative infinity? That is why when we go to our calculator, it says it's undefined. Because if we approach it from two different sides, we get to very different things, right? They might look the same, but positive infinity and negative infinity are all the way on opposite sides of the number line, very different. Okay? I'll do a quick graphical representation of this because it's sort of cool. Desmos. So here we have the function f of x equals 1 over x. And you can actually see what's going on here. As x goes to infinity, so as x goes to infinity along this curve, you'll see that the function approaches the x-axis. It's getting smaller and smaller. It approaches 0. And we can actually see that if I go over this side from the negative side. As x gets larger and larger and larger from the negative side, we get that it approaches 0. At the same token, notice what happens around 0. On one side, on the negative side, it's going to negative infinity. Again, so if you follow the arrow that I'm, like my cursor here, through the direction of our limit, right? This going this way would be the limit as x goes to 0 from the negative side. And going this way would be x goes to 0 from the positive side. And you'll notice that they are, we actually call it, they are diverging. One goes to positive infinity, one goes to negative infinity. So in that sense, 1 divided by 0 is undefined. Okay, cool.